So now let's prove c0 square plus c1 square plus c2 square plus so on plus cn square is equal to 2n cn. So whenever there is a multiplication of two coefficients, two binomial coefficients, you have to take the expansion of two different expressions, say 1 plus x whole to the n, or 1 or x plus 1 whole to the n. Depending upon the signs between the coefficients, you have to take plus or minus. So here we'll take plus on both sides. So here 1 plus x whole to the n is expanded in this way, and x plus 1 whole to the n is expanded this way. And once you multiply both equations, this and this, you get 1 plus x whole to the 2n is equal to c0, which is the first one, plus c0 x to the n, so on, which is the second term. So here you got to see the question. What's the question? The question is c0 square. So how do you get c0 square? By multiplying c0 here and c0 here. So what expression or what term you need to compare on both sides? That's pretty clear. That's x to the n, because this term times this term is x to the n. So let's compare terms of x to the n both sides. Let's start with the left hand side, or sorry, right hand side. Right hand side, if you want x to the n, that is by c0 times c0 x to the n. So you get, let's take different color. So you get c0 times c0 x to the n plus c1 x times c1 x to the n minus 1. c1 times c1 x to the n minus 1 times 1 plus 1 is n. Similarly, you get c2 times c2 x square plus x to the n minus 2, which is x to the n. So c2 times c2 x to the n plus so on, plus cn x to the n times cn is cn times cn x to the n. This is the right hand side. Now let's do the same thing on the left hand side. Let's compare the terms of x to the n on the left hand side. So let's expand 1 plus x whole to the 2n. You get 2n c0 plus 2n c1x plus 2n c2 x square plus so on, plus 2n cn x to the n plus so on, plus 2n c to n. So what is the term of x to the n here? That is 2n cn. See, if you equate these two terms here, because this is the terms of x to the n on the right hand side, and this is the term of x to the n on left hand side. So you have to equate this with this, and if you take the x to the n as a common factor out, then you'll end up with c0 times c0 c0 square plus c1 times c1 is c1 square plus c2 times c2 is c2 square plus so on, plus cn times cn is cn square is equal to, on the left hand side, the term for x to the n is 2n cn, which is what you need to prove here. So whenever you have the multiplication of two binomial coefficients, you always have to expand any two equations and then compare the coefficients of the term which is shown here. For example, here c0 square, that is c0 times c0, which is x to the n. So you compare the x to the n term here. If it is c0 times c1, then you compare this times this gives you x to the n minus 1. So you would compare x to the n minus 1. If it is c0 times c2, then you compare x to the n minus 2 and so on.